Today I will be talking about section 3.1, Differentiation Rules. Video by L. McHugh. To start off, I will be talking about some rules you need to know for this section. The derivative of a constant function is equal to 0. The power rule. The constant multiple rule. The sum rule. The difference rule, in that the derivative of e to the x is equal to e to the x. Some other problems to keep in mind would be the derivative of 1 over x. So first, you need to bring the variable that you're finding the derivative of into the numerator. Then you just use power rule. So you would bring down the exponent and then subtract 1 from the exponent. This is negative 1 over x squared. Another example you should keep in mind is the derivative of the square root of x, which is equal to the derivative of x to the 1/2 power, and then you apply power rule. So you bring down the exponent, subtract 1 from the exponent, and then to simplify, you would just do 1 over 2 square root x. You will also be required to apply these rules. This problem requires you to find the slope of the tangent line at x equals 3 on the graph of f of x. The first step is to take the derivative of f of x, taking power rule of each term. Then you plug in x equals 3 to this equation, and you get the derivative at 3 is equal to 39. This is the slope of the tangent line at x equals 3. Now let's say you were required to find the equation of this tangent line. First you would plug in 3 to the original equation to find your y value. Now you have a y, x, and your slope, so you can just plug it into point-slope form. Then you can make this into slope-intercept form to get your final answer. Another problem is the equation of motion of a particle is s of t. Find the velocity and acceleration functions. So the velocity function is the first derivative of a motion function, while the acceleration function is the second derivative of a motion function. So what I did is I took the first derivative of s of t using power rule to get the velocity function. Then I took the derivative of that using power rule to get the acceleration function. This will be applied later when you want to find when a particle is speeding up or slowing down on an interval. Another problem you'll need to know how to solve is how to find a cubic function whose graph has horizontal tangents at 1, -4 and 0, 3. First you want to find the derivative of this function. So y prime is equal to 3ax squared plus 2bx plus c. You also want to plug in the points given to the equation. Then you simplify. Then you plug in the other point. Now with this equation, all of these terms become 0, leaving d is equal to 3. You can also put this 3 into this equation for d, making that -7 equals a plus b plus c. Then you apply these points to this equation. So since you know that the tangents are horizontal, they will have a slope of 0. So you can plug in 0 for y prime and 1 for x. Then you simplify. You can plug in your other point as well, which simplifies to c is equal to 0. Then you can plug in 0 for c wherever you have equations, which makes 0 is equal to 3a plus 2b, and -7 is equal to a plus b, taken from there and there. What you have to do now is multiply this equation by -2, so that you can cancel this 2b out with this 2b. Then you add these two equations together to make a is equal to 14. Then you plug in this 14 to this equation to get b is equal to -21. So now that you have your values for a, b, c, and d, you can plug that into the original equation for the cubic function to get this final function. As you can see here, there are horizontal tangents at 1, -4 and 0, 3. On the AP test, you might be presented with a problem like find the equations of two tangent lines to the parabola y is equal to x squared plus 3 that pass to the point 1, -5. The point 1, -5 is not on the parabola, but the tangent lines just pass through this point. So to solve this problem, you must use the algebra slope and the calculus slope. The calculus slope in this case is the derivative of this function. Y prime is equal to 2x using power rule. To find the algebra slope, you have to use the equation Next, I plug in this equation to y2 and then just x to x2 and -5 to y1 and 1 to x1. Then I set this algebra slope equal to the calculus slope. Next, I cross multiply and put all of the x terms onto one side, setting it equal to 0 so that I have a quadratic function. Then I factor this equation. This means that x is equal to 4 and x is equal to -2. So now I have to solve for the equations of two separate x values. First, I'm going to find the y value for each of them by plugging this into the original equation. Y is equal to 4 squared plus 3. Y is equal to 19. Then I solve for the slope using the calculus slope. So y prime is equal to 2 times 4. Y prime is equal to 8. Now I'm going to do the same thing using x is equal to -2. So now that I have all of these values, I can plug them into the equations using point-slope form. Your final answer are these two equations that represent the two tangent lines to the parabola y that cross each other at the point 1, -5. So now I'm going to go over 3 common mistakes. The first common mistake is treating a constant like a variable. For example, if you are trying to find the derivative of a squared x squared, some may do 2a times 2x. But this is very wrong because a squared is a constant. So what you actually should be doing is keeping a squared the same and just doing the power rule of x squared, making the final solution 2a squared x. Another common mistake would be not bringing x to the numerator if you were taking the derivative of 1 over x squared, for example. Some may do 1 over 2x and call that their final answer, but that is very wrong. What you have to do is you have to bring x squared to the numerator, making that the derivative of x to the -2, which is equal to -2 over x cubed. Another common mistake would be involving a problem like what I showed earlier. One might think that this point is on the graph of the parabola y equals x squared plus 3. But the question explicitly states that the two tangent lines just pass through the point 1, -5. So they might solve this problem like I solved this problem, which is very wrong. Thank you for watching this video. The worksheet and key will be linked in the description box below.